For 4.5 billion years, the Earth has been blasted, burned, ripped and scoured. These phenomenal events have sculpted our planet through a series of devastating cataclysms. Understanding Earth's tumultuous history is like reading an intricate detective story, for the Earth is unlike any other planet. Its restless surface is changing constantly, destroying the evidence of the past. But if you know where to look for them, the clues are still there.
I'm going to attempt to scoop a sample of molten lava. It'll be extremely hot. We have to worry about gases, and we have to worry about breakouts near the edge of the pond.
The Atlantic Ocean owes its very existence to the geological violence that took place 135 million years ago. The supercontinent began to split apart, and as it did so, there must have been a time when ocean waters rushed into the widening gap, forming a new ocean basin.
What makes these caves particularly exciting is that they are one of the last unexplored frontiers and turned out to be one of the world's largest and longest known cave systems.
What I find truly remarkable is that within this core barrel is a massive piece of rock from 200 feet below the surface, and yet it contains as many bacteria in it as there are people on this planet.
Ocean basins open and close. The sea covers the continents and then retreats. Mountain ranges like the Himalayas and the Andes will be eroded flat. On a human timescale, not much changes. But on a geological timescale, the whole Earth is remodeled, and all the things that we've done and made will be destroyed.
About 18,000 meteorites hit the Earth every year, hurtling down at 70,000 miles an hour. Most are small and do little damage, but each brings clues to the catastrophic formation of our planet. Geologist Roger Buick is working in northwestern Australia.
Even though it's just arrived, this is the oldest thing on Earth. It's a chondrite, a type of stony meteorite, and it's been wandering around the solar system for about 4,500 million years. And it's stuff like this that the Earth is made of, space junk glued together.
4.6 billion years ago, the molten Earth grew as a continual rain of mega meteorites pummeled it on its orbit around the Sun. Each strike brought with it raw rock, the material from which Earth could grow. It also brought explosive energy, raising the surface temperature of the primitive planet to over 1,800 degrees. A vast ocean of molten rock, 100 miles deep, covered the globe. Internal radioactivity raised the temperature even further. Earth became a melting pot, soon passing the melting point of iron. The meteoric iron began to sink to the center, dragged by the relentless tug of gravity. A kilometer sphere of molten iron would make the journey from the surface to the center of the Earth in less than 1 million years, a blink of geological time. The constituents of the Earth were forming. It had an iron core surrounded by molten rock. On the surface, a thin crust was developing. It behaved like these molten lava ponds, and the turbulent forces beneath began to fracture the crust. These are the tectonic plates, vast sheets of the Earth's crust moving endlessly, tearing and crashing over the planet's surface. The process is still going on. In some places, the plates are forced apart and molten lava is driven through the seams to create new crust. Elsewhere, crust is destroyed where plates collide. One is forced back into the molten mass beneath. Along these subduction zones, volcanoes erupt. Soon after its violent beginning, the planet was to suffer the most ferocious assault imaginable. A rogue asteroid bigger than Mars smashed into it with enough power to blast much of the Earth's surface into space. The debris was drawn together by gravitational forces and formed a proto-lunar disk. From that, the new moon grew rapidly, sweeping up the debris in orbit around the Earth. Computer models suggest it only took a year for the fragments in orbit to coalesce and form a single moon. Professor Michael Rampino of New York University knows its history mirrors our own violent early years.
This is the Clark telescope at the Lowell Observatory in Flagstaff, Arizona. It's a telescope that was used to take pictures of the moon in preparation for the Apollo moon landings. To see the moon tonight, we need the telescope up in this position. And we can make some fine adjustments. The density of the craters on the moon's surface was measured using the photographs taken by the Clark telescope. What's more, the astronauts visited some of these regions in their 6 Apollo missions.
Man, does this thing have steep walls. They said 60 degrees. Now, I tell you, I can't see to the bottom of it, and I'm as close to the edge as I'm going to get. That's the truth. I can't believe we came over those mountains.
The largest impact feature on the moon, the Imbrian Basin, is more than 1,000 kilometers across. It was produced by the impact of a comet or asteroid more than 100 kilometers across.
Yeah, those are pretty big mountains to fly over, aren't they?
The basin is surrounded by mountains more than 5 miles high. This is where the Apollo 15 astronauts landed and took samples. They show that these mountains are not like the mountains on the Earth, but they're piles of rubble, fragmented rock thrown out by this giant impact.
Look at that. Guess what we just found? I think we found what we came for. Crystal rock, huh? Yes, sir. You better believe it.
The pristine moon rocks that were brought back by the Apollo astronauts have been radiometrically dated and studied. And they show that impact has been an important process in the formation and evolution of the Earth-like planets. What's more, the radiometric dating of the rocks has shown that the moon underwent a hellish bombardment between 4.5 and 4 billion years ago. After that time, the bombardment died down. By that time, most of the asteroids moving around in the inner solar system had collided with the planets, and the process of formation of the planets was over.
3.5 billion years ago, the Earth began to cool. Water vapor and acidic gases were being released from the hot interior on the breath of giant volcanoes. This was the Earth's Big Burp. The result was a thick, steamy atmosphere with pressures 100 times greater than they are today. The only landscapes were volcanic frozen lava and yellow ash. There was no surface water. This harsh terrain had yet to be sculpted by erosion. There was moisture in the atmosphere, condensing in pockets, but not enough to create oceans or rivers. There was no oxygen in the air. It was inhospitable with no trace of life. A new theory suggests that in time, water, maybe enough to fill the world's oceans, arrived from deep space, brought on ice comets. Cosmic rain continues today with small 20 to 40 ton ice comets striking the Earth's atmosphere once every 3 seconds. They add 1 inch of water over the entire surface of the globe every 20,000 years. When the atmosphere was saturated, the rain began. Over the eons, the torrential storms produced the greatest floods the planet has ever known. an endless ocean grew, and when the skies finally cleared, the Earth had been transformed into a watery globe. This is the time when life is thought to have begun. Echoes of those beginnings can still be heard today. Our most ancient ancestors, the most resilient creatures ever evolved, have survived unchanged for billions of years, living in solid rock. Drilling to great depths into the rocks at Idaho Falls, Princeton microbiologist Tallis Onstott is hoping to take a closer look at their descendants.
Okay, thanks, Frank. What I find truly remarkable is that within this core barrel is a massive piece of rock from 200 feet below the surface, and yet it contains as many bacteria in it as there are people on this planet. Now, these are living bacteria, and they live at temperatures approaching the boiling point of water. They live at pressures that are 100 times the atmosphere. They live in a salty, briny solution that's alkaline and contains gases that are toxic to us, and yet they still manage to survive.
They're known as extremophiles because of their extreme living conditions. To get a closer look, the scientists first extract them from their rocky home.
The really exciting thing about heat-loving bacteria is that they're the most primitive organisms on the Earth. And the fossil evidence in the most ancient rocks on Earth indicate that these types of organisms must have existed 3.7 billion years ago.
With skill and care, the team work inside glove boxes. Here they can manipulate the sample under sterile conditions. They go to great lengths to ensure that the only bacteria inside the tent are those that have made the journey up from the Earth.
We need to pare away the outside of the core so that we can remove any contamination that may have occurred during the process of coring in the field.
The core is then placed in a press and crushed to a fine powder. Then a sample is taken from the powder and a culture developed of the bacteria. These are the earliest common ancestors of all life, a colony of extremophiles. Observing how microbes survive thousands of feet below the surface, some scientists have speculated about life elsewhere. Could there be tiny extraterrestrials buried in the same way on other planets that appear outwardly sterile? The same kind of bacterial life was finding an equally unlikely home in the deep oceans of the primitive Earth. Water welling up from deep below the ocean floor must have carried the microorganisms into a warm volcanic crucible. Nearly 9,000 feet down, the sea floor is split into the great mid-ocean ridges. The crust is very thin, and the volcanic heat from the Earth's core heats the water which floods out through black smokers. Here, strange communities of microorganisms thrive on the chemically rich mixture. These bacteria endure pressures 3,000 to 4,000 times greater than those on the surface and support a bizarre array of creatures. They can survive here because of the heat escaping from the molten core only a few miles beneath. It's not only life that began here, but the actual fabric of the land itself. Where the tectonic plates that form the ocean floor are torn apart, new lava continually emerges and new volcanoes are born. In 1963, this act of creation could be seen by all. Some 10 billion square feet of lava erupted off the coast of Iceland to form the new island of Surtsey. It emerged in a matter of days, just like volcanic islands on the primitive Earth. All over the planet, these islands appeared, and in time, they were to form the first continents. Clues as to how this happened are found in the Canadian Rocky Mountains. The outer shell of Earth, the lithosphere, carries the continents. It's made up of great stratas of different rocks extending 60 miles down into the earth. Most of its structure is unknown. The deepest man has ever drilled is 9 miles. Exploring deeper needs a different approach. To discover just how their land was formed, a team of 700 scientists, the modern equivalents of early map makers, are charting this invisible territory. They use shock-wave detectors, geophones, which the teams are placing all over the landscape. This is the world's biggest subsurface exploration experiment, the lithoprobe. In the Yukon province, the chief scientist is Charlie Roots.
Geologists who work in sedimentary rocks are used to continuity, both in oldest rocks to youngest rocks, as well as being able to take the same rock formation for a long distance. You can't do it in these mountains. The rocks on the surface indicate a large platform of limestone, and the surrounding areas are rocks that have no relation to that. They are bits that are not part of the continent that appear to have come from somewhere else. These canyons show the folds and the twists that the rocks have undergone as they've been pushed up against the ancient continent. The problem is that we only get to see the rocks that are at the surface, and in an area where rocks are steeply dipping, there is far more of the story buried beneath our feet.
To send shock waves deep into the crust, 200 pounds of explosive are buried in the ground.
We're digging 3 holes for the geophones that we're going to be putting in here so that we can have a 3-component orientation system to measure the seismic wave that comes in. We have a vertical geophone, which will measure the vertical component of the arriving wave. There is a north-south geophone that will measure the north-south component of the incoming wave. And we have an east-west geophone to measure the east-west component of the incoming seismic wave.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Shockwave races down through the ground. They hit something hard, much harder than the surrounding rock. The shock waves are reflected and speed back to the surface, taking their precious information to the geophones. Analysis of the results shows that under the Rockies are the buried remains of ancient volcanic islands. Over the last 200 million years, hundreds of these islands were grafted onto the North American continent. They form much of the land west of the Rockies, stretching from Mexico to Alaska. This is a clue as to how the first land masses were created. But until very recently, science was at a loss to say just when it happened. Then one day, prospecting for minerals in northwestern Australia, Roger Buick made a startling discovery. This rock is part of the oldest land surface on Earth. It has miraculously survived the never-ending cycle of formation and destruction of the crust. The vertical stripes have endured for over 3.6 billion years, giving a date for when the land began. Nearby, in the younger sedimentary rocks of the Carragini, are all the clues to solve another chapter of Earth's history. This was the first place where life and the land began to interact, and the traces are clear to this day.
The impressive thing about the place is how red it is. In fact, red rocks stretch for hundreds of miles in every direction. The reason they're red is because of this red mineral, hematite, iron oxide, or rust. And the way they formed was when dissolved iron in the ocean combined with oxygen and precipitated out as iron oxide, settled down to the sea floor and accumulated on the bottom of the sea. Initially, the atmosphere of the Earth had no oxygen. The same applied to the oceans. These rocks record an intermediate period when there was still no oxygen in the atmosphere, but the upper layers of the ocean contained oxygen. There's a huge amount of iron oxide here. The sheer volume suggests that the oxygen could only have had one plausible source: biology, living organisms excreting oxygen as a byproduct of photosynthesis.
After 2 billion years, the oxygen had finally combined with all the iron. For the first time, free oxygen was able to escape into the atmosphere, and the air became breathable. Deep into the Australian outback is more evidence of primitive oxygen-producing organisms. In a secret location Buick discovered are some of the world's oldest and rarest fossils.
What I've done is step back more than 3/4 of the way back to the beginning of Earth history. And here are wrinkly layered sediments that occasionally dome upwards. And these are stromatolites, sedimentary structures created by filamentous microorganisms trapping sand and mud between their little filaments. Those microorganisms were probably photosynthetic. The layers thicken over the tops of these domes, competing with each other to get nearer the sunlight. Now, these stromatolites are remarkable for their great age, 3,450 million years old. Not only are they remarkable for that, but we can also infer something about the environment in which they lived. Just back here are gypsum daisies, little star-shaped clusters of gypsum crystals, calcium sulfate. These form when seawater evaporates in a shallow pond near the edge of the sea.
By producing oxygen, stromatolites change the planet forever. These tiny bacteria were the first organisms to live together in colonies. They capture and incorporate fine sand to create rocky structures which still survive in Australia today.
Living stromatolites only grow when they're almost permanently submerged in water, so you only see them exposed at very low tide. These grew here about 5,000 years ago, when the sea level was about a metre or so higher. The living carpet of bacteria that formed them died off as the sea level gradually dropped, and the sediment that the bacteria trapped was turned into limestone.
Life flourished and became a force to shape the world. In Utah, the shells of countless millions of marine creatures which lived and died here have been exposed where the San Juan River creates a great tear in the Earth's crust. The river has revealed a lost world where shallow seas once lapped the shores of the world's only landmass, the giant supercontinent Pangaea. "200 million years ago, the Colorado Plateau was a desert in equatorial Pangaea, the supercontinent which stretched unbroken from pole to pole. "50 million years ago, this entire region underwent a cataclysmic change. Erosion began relentlessly stripping away layer upon layer of rock. The tectonic forces which squeezed, compressed, and lifted the land were locked in an endless battle with erosional forces, carving the land flat again, shaping fantastic landscapes. Volcanic rocks that never managed to force their way to the surface are revealed. The granite was formed when the land was buried under a mile of sandstone. Erosion scrubs away the surrounding softer sedimentary rock, leaving the hard, igneous bones of the emerging hills. Water is the strongest force of all. It cuts through solid rock to create deep canyons. With terrible patience, it will scour away the stone and shape the rocks. One day, in an unimaginably distant future, Antelope Slot Canyon will be as wide and as deep as the Grand Canyon itself. The 1,000-foot-high sandstone pillars, buttes, and mesas that rise above the plains are the memorials to millions of years of the geological battle. But they too will disappear. Nothing can withstand erosion. As fast as tectonic forces raise landscapes, wind, rain, and gravity will erode them down again. Sculpting the surface, gouging out the deepest ravines, cutting down the tallest mountains, nature finds its own equilibrium. In the end, it will obliterate all the structures the Earth creates. "200 million years ago, the supercontinent Pangaea began to split in two. It took 65 million years. Two continents we know today were shaped by another upheaval that hit the remains of the supercontinent in the south. In the jungles of South America, I found one of the most remarkable features on the face of the planet. This whole landscape owes its existence to this violent chapter of Earth's history. The hope of finding more clues to this catastrophe has drawn Professor Michael Rampino here.
Iguazu Falls, Argentina. For me, the most spectacular waterfalls in the world. Not only because of the spectacular scenery here, 250-foot-high waterfall, a mile wide, but because of the spectacular geology. What's more, the rocks of the falls contain evidence pertaining to a geological event that took place here 135 million years ago. The geological evidence is here in these rocks. This is basalt, a hard volcanic rock, stained red by iron oxide, oxidation of the iron within the rock. In fact, we're standing here at the base of a basaltic lava flow more than 100 feet thick. Just one of many lava flows in this area, which form a pile of lava more than a mile thick. In fact, in the waterfalls, one can see steps of the waterfalls, which shows the individual lava flows in this pile. Imagine volcanic eruptions so enormous as to produce lava flows erupting from giant cracks and fissures in the Earth's crust, flowing out over an area twice the size of the state of Texas, more than 250,000 square miles. An enormous volcanic event. Massive amounts of sulfur-rich gases spewing into the atmosphere, droplets of sulfuric acid forming a veil that cuts out the sunlight and cools the climate, sulfuric acid rain killing the vegetation, the makings of an environmental disaster of enormous proportions. This is 135 million years ago, at the end of the Jurassic period of geological time, a time when there were mass extinctions of many forms of life. There's evidence here in these rocks for even more dramatic event in the history of the Earth. And here's just the piece of evidence that I need.
On the other side of the world, across the Atlantic Ocean, is the world's most ancient desert. It dominates most of the southern African country of Namibia.
I've traveled more than 4,000 miles, and the rocks are exactly the same. They're basalts, and the age is 135 million years. Clearly, when these rocks were erupted, as floods of lava traveling hundreds of miles, South America and Africa were together as one supercontinent.
The Atlantic Ocean, which now divides Africa and South America, owes its very existence to this geological cataclysm that tore Pangaea apart.
The supercontinent looked like this, made up of the present-day continents of Africa, South America, India, Antarctica, and Australia. The cracking started here and split the continent into the present-day continents of South America and Africa.
In geological terms, it happened incredibly fast. The crack opened northwards at a speed of 2 inches per year, the split unzipping the land as it went along. Fountains of volcanic fire leapt through the crack. The entire process took only 5 million years to complete. Evidence of the unzipping is clear. The shorelines of South America and Africa match perfectly, and under the ocean, the mid-Atlantic ridge divides the 2 continents almost exactly down the middle, where it still pushes them apart. But geological upheavals can spell disaster. There have been 5 key mass extinctions in Earth's history. Best known are the dinosaurs. Why did they simply disappear from the face of the Earth? India may provide the answer. 65 million years ago, it was still an island drifting towards Asia. This was when the layered landscapes of the Deccan Traps were created. A great volcanic rift spewed out 500,000 square miles of lava. Layer after layer of lava lies on the land in places up to 8,000 feet thick. Some scientists believe that the scale of this volcanic activity was so great it killed off the dinosaurs. Professor Michael Rampino thinks the traps were triggered by an extraterrestrial visitor.
This is the Hoba iron meteorite in Namibia. It's the largest meteorite known on Earth. And like most meteorites, it contains the rare element iridium. And iridium has proven to be the clue, the connection, between the impact event and the extinction of the dinosaurs.
Iridium is found near impact craters, but is extremely rare elsewhere in the Earth's crust. At these craters, the levels of iridium are 10,000 times higher than normal. Such high concentrations have been found in the sedimentary record all over the world at a consistent date of 65 million years ago. Recently, a crater more than 110 miles wide was detected off the coast of Mexico's Yucatan Peninsula. It too was created 65 million years ago. It was formed by a 10-mile-wide cosmic killer which closed on Earth at more than 60,000 miles an hour. It struck with the violence of the world's entire nuclear arsenal exploding 1,000 times over. It sent out a ferocious fireball engulfing the land for thousands of miles around. Enormous fires raged for months, destroying everything in their path.
The impact may have had other catastrophic effects as well. The force was so great that shock waves went out from the point of impact in Mexico around the world and focused and concentrated at the exact opposite point of the Earth, in the Indian Ocean.
The exact opposite point in those days was the island of India, and Rampino believes the violent volcanic eruptions which created the Deccan Traps was triggered by the meteorite. The effects of the impact explosion and the volcanic flood poured millions of tons of dust and ash into the air, plunging the world into darkness. Nitrogen, sulfur, and oxygen in the atmosphere combined to form acid rain as the Earth cooled. In this cosmic winter, 75% of all living things perished. When the skies cleared, the dinosaurs had gone. India continued on its race towards Eurasia. About 45 million years ago, they crashed together and began the fight for supremacy. Neither would give way. Too buoyant to be drawn back into the molten center of the Earth, they crumpled, folded, and doubled, leaving the crust only one way to go, skywards. The early Himalayan mountain chain was raised from sea level to 5 miles high as India penetrated a distance of more than 1,000 miles into Asia. At about this time, the Earth started to get much colder. There is evidence for many ice ages during Earth's history, but the last full and most severe one began 45 million years ago, just as the Himalayas were being formed. One theory attributes the dramatic cooling to this tectonic turmoil. The collision raised the ocean floor and with it limestone high into the atmosphere, exposing it to erosion. The mountains are littered with limestone rocks and rubble. This debris would combine with rain and carbon dioxide in the air in a chemical reaction which removed millions of tons of the gas from the atmosphere. With less greenhouse gas to keep it warm, the entire planet would cool, triggering the Ice Age. The poles were now permanently covered by ice over 2 miles thick. At the edge of the vast ice sheets, immense glaciers advanced relentlessly. Nothing could resist as they raced forward at speeds of up to 10 feet per day. The ice covered more land, so more of the sun's heat was reflected back into space, chilling the planet further. At its coldest, Earth was covered by 3 times the volume of ice on the planet today. This ice locked the water away, trapping it on the land. With less available water, the world's sea level dropped by 425 feet. Today, the Caribbean island of Grand Bahama holds the clearest clues to the dramatic change in past sea levels. Microbiologist Steffi Schwab has been piecing the story together. Hidden deep in a mosquito-ridden mangrove swamp is a tannin-stained pool, an unlikely entrance to a mysterious ancient world.
These caves have a story to tell concerning past sea level fluctuation and past interglacial and glacial periods. What makes these caves particularly exciting is that they are one of the last unexplored frontiers, and they turned out to be one of the world's largest and longest known cave systems. We move from the entrance into a very large cathedral room where we can see the ceiling comes up to what we commonly call these cave systems, which is a blue hole. You always find, when you go into these large cathedral rooms, a very large rock pile in the center. And usually the collapse happens when the water is no longer in the cave, supporting the ceiling. I'm now swimming through what is called a mixing zone, and this is where the fresh water mixes with the seawater and causes what we call a shimmer. This mixing zone is responsible for aggressively attacking the wall rock. It's like soft cheese. Normally, limestone could not be removed with your finger. You would need a rock hammer and a chisel. This is how we know that the caves have formed hundreds of thousands of years ago. But we also know by evidence that we have found that the caves have been dry in the past. 20 meters down further into the cave system are these bat droppings that have been fossilized. And we know the only way that this can happen is when the caves are dry, because bats do not swim. And when bats roost in the ceiling, the droppings collect on the rock and they become very hard. Deeper into the cave system, we find another bit of evidence, and that is this red Saharan dust, which gets blown into the stratosphere during frequent storms which occur in the Sahara Desert, and will actually find its way into these caves. Most likely it's happened during periods when the cave was dry. The final bit of evidence which supports the fact that the caves have been dry are these beautiful stalactite and stalagmite gardens that we find at 28 meters plus. Stalactites and stalagmites form during the ice ages and have formed over a period of hundreds and thousands of years. What happens is the water is frozen in the ice caps on the poles, sea level drops, and the caves become dry. And usually during ice ages, it rains a great deal more in the tropical regions of the world. This rainwater percolates through the bedrock or the sealing rock and dissolves the rock that's there, and it comes out in the drip water and crystallizes, just like an icicle. And basically, these are rock icicles.
The ice ages affected and shaped the landscapes, but sometimes the clues are so gigantic it's hard to recognize them. In Washington state, in the Grand Coulee Canyon, are the channeled scablands. For years, a succession of scientists tried to work out what could have caused erosion on this scale. USGS scientist Richard Waite is the latest investigator.
This rock, the size of a 3-story house, looks like it's part of the bedrock, part of this basalt that forms this vast landscape. But the structure in the basalt is horizontal, as you can see, whereas the structure in this rock is vertical. In other words, this big rock has been moved. The rock can't have just simply rolled off the cliff. We're too far from it, and there's a valley between us and it. Glaciers have been known to move rocks this size, but we are beyond the glacial limit. But the biggest clue in the landscape is the landscape itself. This gorge is carved in basalt, one of the hardest of rocks. It ends in a sheer cliff, 400 feet high, and it's in the shape of an enormous horseshoe. It's like the gorge below Niagara Falls, but this, Dry Falls, is fully 2 Niagaras high and 3 wide. And yet this gorge and these vanished falls, enormous as they are just but one element in a large landscape.
Waite is continuing the work begun by geologist J. Harlan Bretz in 1923. Bretz was the first to say that this entire landscape was a gigantic riverbed formed by 3,000 square miles of the Columbia Plateau being swept away. No one believed him because the scale was so huge, but he was certain that the only explanation for this scale of damage was an enormous flood. The whole area was obliterated and changed forever as the torrent flooded through. Even on the top of the cliffs, the water was over 100 feet deep.
One of the things we see when we get down flying in the cataract, we're about 100 feet below the level of the water, is the enormity of this cataract. The walls extend for miles, many miles, 17 miles in fact. Continuous vertical cliffs and basalt.
The basalt cliffs are amongst the hardest structures found in nature. Resistant to weathering and erosion, these walls could only have been cut by an enormous body of water. One by one, these columns of frozen lava were quarried from the rock face and carried away by the raging torrent, causing the wall to retreat and the cataract to widen. So it was accepted that this is how the channeled scablands were shaped. But an important part of the mystery remained. Just where could all that colossal, earth-shattering volume of water have come from?
100 miles to the east, geologist Joseph T. Pardee had described an enormous Ice Age lake, Glacial Lake Missoula. This lake held in some 600 cubic miles of water. 600 cubic miles is all of present-day Lake Erie, plus all Lake Ontario. The lake was held in by an ice dam that had crossed the Clark Fork River and dammed it. The lake rose 2,000 feet deep against the side of the ice dam, but there was no evidence to link the lake with the Channel Scabland. In 1939, Pardee discovered a series of giant ripples. These are like sand ripples on the beach, but they are of enormous size, hundreds of feet apart, 10 feet high and more, and they're composed of gravel. Such a feature could only indicate a swift outflow from Glacial Lake Missoula.
The gigantic ice dam held back the water until it reached a critical level. When it was 1,800 feet deep, the pressure of the water was so immense that it forced its way through the base of the ice dam. Having found a weakness, the icy waters raced on, widening the split and weakening the dam catastrophically. The waters of the entire lake were released in a devastating discharge.
This discharge was 10 times the flow of all the world's rivers. That's almost beyond belief. And this great discharge was headed straight towards Bretz's Channel Scabland. Still, parts of this great mystery remained unsettled. For instance, what of this great 17-mile gorge below Dry Falls? According to Bretz's idea, this whole 17 miles would have to be excavated in one flood. One thing Bretz's critics objected to was the enormous scale of erosion so swiftly. More water, they wanted, over far more time.
The answer was found by chance 200 miles away in the Walla Walla Valley. In 1926, a freak flood created a 100-foot deep canyon. It revealed many layers of silt. Waite realized that this area must have been in the path of the great floodwaters that formed the channeled scablands.
Each one of these beds has a distinctive pattern of sedimentation. Each bed begins with a coarse sand at the bottom, and then it grades up to a medium sand, and then finally a silt. And it happens again and again and again, each layer. This white layer here is an ash that we know is from Mount St. Helens. We've analyzed it chemically, mineralogically, and it clearly came from Mount St. Helens. And we know its date. By radiocarbon dating, we know that this is 15,000 years old, approximately. Therefore, we have a beautiful timeline running through this section of 15,000 years.
The ash could only have fallen after the flood had passed and the sediments settled. Yet it's covered by many layers of sediments, 39 in all. This was the final piece of evidence that explained the creation of the scablands. Here was more water over more time. The catastrophic outburst flood must have happened time and again. Once each flood had left its mark, the vast glacial dam would advance and the waters of Lake Missoula would start to rise again, continuing the cycle of flood followed by calm. Only when the time of the ice was over did the flood stop. The change from Ice Age to warmer times is governed by how close the Earth is to the Sun. Every 100,000 years, the shape of the Earth's orbit around the Sun changes. This has led some scientists to wonder if the recurring cycle of catastrophe and extinctions on our planet is governed by extraterrestrial forces.
Mass extinctions and the catastrophes that cause them seem to follow a periodicity of about 30 million years. It's that cycle that suggests that the cause of a catastrophe lies outside the Earth. On a clear night here in Africa or in other places where you can see the night sky, we can see astronomical evidence for the cause of these geological catastrophes every 30 million years. Our solar system is on a voyage through the disk-shaped Milky Way galaxy. Every 30 million years, we pass through the densest part of the galactic disk.
During that time, the comets of our solar system can become disturbed and fall inward toward the inner planets. During this period, the Earth is more likely to be impacted. This cycle may explain the catastrophic history of the Earth. The last major mass extinction was 35 million years ago. We're in the densest part of the galactic disk now, and the next mass extinction may include us.
Cataclysms may have caused extinctions and disasters, but they have also shaped the Earth and produced an environment in which human life could flourish. The air breathable, the seas are warm, climate mild, the ice rooted firmly at the poles. In fact, a geological truce. But that truce may be coming to an end. With man so widely spread across the planet, cataclysms of nature will turn into human catastrophes. The forces that drive the Earth are impervious to our needs. Every movement of the plates brings the danger of disaster nearer. We have to learn that our restless planet will never stand still.